Today we're looking at the work that we covered whilst we were back at school. You want to get a copy of the work, and on the front page we have the 5 questions starter sheet. You want to give these questions a go yourself now, and then once you're done you want to check the answers that will have been provided. After the starter sheet, we looked at revising the algebra that we have covered during lockdown. I will be doing the questions on the left as examples, and you will be doing the questions on the right yourself, and then you can check you're working out with the answers that have been provided. Our first example is 4x equals 12. To solve equations, we need to isolate the term and then isolate the variable. The term that contains x, which is 4x, is already isolated on the left-hand side of the equation. So we go straight to isolating the variable, which is x itself. I need to get x completely by itself, so we need to try and remove the 4 that is in front of x. This 4 is multiplying x, so in order to get rid of 4, we need to do the opposite operation of times 4. That means we need to divide by 4. If I divide the left side of the equation by 4, I also need to divide the right side of the equation by 4. 4x divided by 4 leaves us with just x, and 12 divided by 4 leaves us with 3, and the equal sign is going to drop down from the top line to the bottom line. This leaves us with the answer for this question of x equals 3. On to the next example, we have 15 equals 7x, and the method here is going to be exactly the same. I need to isolate x away from the 7 that's in front of it. So, to undo this multiply by 7 effect on the x, we need to do the opposite operation, which is dividing by 7. We draw a line underneath. 7x divided by 7 leaves us with just x, and again the equal sign is going to drop down, but then we're left with 15 divided by 7. 7 doesn't go into 15 exactly, so rather than writing a decimal, we're going to leave it as 15 over 7. This is a correct answer, and this should be the form that we try to leave our answer in. You should have a go now at the 5 questions on the right hand side, and then once you're done, you should check your answers. The next example is x divided by 3 equals 12. Again, we want to isolate the x term, which means we need to get rid of the divide by 3. To get rid of the divide by 3, we do the opposite operation, which is to times by 3. X divided by 3 times by 3 leaves us with just x. The equal sign is going to drop down, and we do 12 times 3 to leave us with the answer of x equals 36. You should have a go now at the 3 questions on the right hand side. Our next question is x plus 5 equals 12. Again, I want to isolate x to be completely by itself, so I need to get rid of the plus 5 that is also on the left side of the equation. To get rid of plus 5, we need to do the opposite operation, which is to subtract by 5. We also need to do that on the right hand side, so I'll write take away 5 underneath 12. The x is going to drop down as there's nothing underneath it. Plus 5 take away 5 will cancel each other out and leave us with nothing, so I won't write anything here. The equal sign will drop down, and 12 take away 5 equals 7. So the answer for this example is x equals 7. Next, we have x minus 4 equals 9. To isolate x here, we need to undo the subtract 4, so we will add 4 to both sides of the equation. The x will drop down, the minus 4 and the plus 4 cancel each other out, the equal sign drops down, and 9 plus 4 equals 13. So here we have x equals 13. You should have a go at the 6 questions on the right hand side and then check your answers. Our next example is a two-step equation. We look for the term that contains the variable, that's the letter x. We need to isolate this term by itself. Notice here that we're including the 3 with x because that is the entire term 3x. This means we need to undo the plus 5 in order to isolate 3x by itself. To undo plus 5, we're going to subtract 5 from both sides of the equation. 3x is going to drop down as there's nothing underneath it. Plus 5 take away 5 is nothing, so we don't write anything down. The equal sign drops down, and we have 17 take away 5 for 12. This is not the final answer for this question because we have not isolated x by itself. So here, to isolate x, we now need to get rid of the 3. 3 is multiplying x, so in order to get rid of the 3, we do the opposite operation, which is to divide by 3. 3x divided by 3 is just x. The equal sign drops down, and 12 divided by 3 is 4. So the solution for this example is x equals 4. This next example is very similar. We need to circle the term that contains the variable. That's 4x. I need to isolate 4x by itself, so we need to get rid of the minus 3 that's on the same side of the equation as 4x. To get rid of minus 3, we need to add 3 to both sides of the equation. If we read down the page, 14 add 3 is 17. The equal sign drops down. The 4x will drop down. But minus 3 add 3 will cancel each other out and leave us with nothing. Again, we're not done because x is not isolated by itself. So here we circle the x and we need to get rid of the times by 4. So both sides will be divided by 4. Here we need to do 17 divided by 4, but again, 4 doesn't go into 17, so we're just going to leave this as a fraction of 17 divided by 4, and that will be equal to x. So our answer here is 17 over 4. Now have a go at the 5 questions on the right hand side and then mark your answers. The next page doesn't have any examples, but it has some extra questions for you to practice. Again, have a go at these questions and then mark your answers. We now move on to the next part of the booklet, which looks at equations that have unknowns on both sides of the equation. These questions are a bit more tricky, but again, I'm going to go through the examples on the left and you're going to do the questions on the right. Our first question, 6a plus 7 equals 2a plus 15, we start by circling both of the terms that have a variable. That's 6a and 2a. We need to decide out of these two terms which term is the smallest. Well, 2a is smaller than 6a. This means we need to undo the 2a. This 2a is being added to 15, so to undo this add 2a, we're going to subtract 2a from both sides of the equation. So I write minus 2a underneath the 2a, but I also write minus 2a underneath 6a. Again, we're looking down the page to do the calculation. 6a take away 2a is 4a. The add 7 has nothing underneath it, so that's going to drop down. The equal sign is also going to drop down. 2a take away 2a is nothing, so we don't write anything here, but the plus 15 is going to drop down. We now have a one-step equation, which are like the questions we were looking at earlier in this lesson. I need to isolate the 4a term, as that still contains the variable. This means I need to undo the plus 7 to have 4a completely by itself. So we're going to subtract 7 from both sides of the equation. The 4a is going to drop down. Plus 7 take away 7 cancels each other out. The equal sign drops down, and 15 take away 7 is 8. We're still not done. A is not completely isolated. So now I need to get rid of the times by 4 in front of A. So we're going to divide both sides by 4 to leave us with A equals 2. You should now have a go at the questions on the right hand side and then mark your answers. For the next example, again we're going to start by circling the terms that contain the variable. That's 5b and 9b. We need to select the smallest of these terms, and that's going to be 5b. So to undo the 5b, we need to subtract 5b from both sides of the equation. 5b take away 5b is nothing. The plus 12 is going to drop down. The equal sign drops down. 9b take away 5b is 4b. And the take away 3 is still going to drop down. Now we need to isolate the term that contains the variable. Well, now that's 4b. So to undo this take away 3, we're going to add 3 to both sides of the equation. 12 add 3 is 15. The equal sign drops down, and the 4b will drop down, with the minus 3 and the plus 3 cancelling each other out. Now we need to isolate the variable, which means I need to get b by itself. So to undo this 4, we're going to divide both sides by 4. 15 divided by 4, we're going to leave as a fraction, and 4b divided by 4 leaves us with b. You now need to have a go at the two questions on the right hand side and then mark your answers. Our next example is similar. We start by circling the terms that contain the variable. That's 6a and minus 4a. It's really important to include the negative sign for this term. That's because when we decide which one is the smallest term, well, that's going to be minus 4a. So to undo taking away 4a, we're going to add 4a to both sides of the equation. 6a add 4a is 10a. The minus 13 will drop down. The equal sign will drop down. The 7 will drop down. And the minus 4a and plus 4a cancel each other out. Now we need to isolate the term that contains a. So we need to get 10a by itself. This means we need to undo subtract 13. So we will add 13. The 10a will drop down. The minus 13 and the add 13 cancel each other out. The equal sign drops down, and 7 add 13 leaves us with 20. Now to isolate the variable, we need to get rid of the 10. So we divide both sides by 10. This leaves us with the answer a equals and then 2. Have a go now at the two questions on the right hand side and then check your answers. Next we have 12 minus 3a equals 26 minus 5a. We start by circling the terms that contain the variable. That's minus 3a and minus 5a. Both of these terms are negative, so it's really important we still pick the smallest term, and that's going to be minus 5a. We need to undo minus 5a, so we will add 5a to both sides of the equation. The 12 will drop down. Minus 3a add 5a is positive 2a. The equal sign drops down. 26 drops down, and the minus 5a plus 5a cancel each other out. Now we need to isolate the term that contains the variable, so we need to undo this 12. This 12 was being added to 2a, so to get rid of the 12 we will subtract 12 from both sides of the equation. 12 take away 12 cancels, the positive 2a will drop down, the equal sign will drop down, and 26 take away 12 is 14. Now we need to isolate the variable, which means we need to get a by itself, so we need to undo this plus 2. Now here it's really important that the opposite operation is not subtract 2. That's because this plus sign is not between 2 and a. What 2 is doing to a is multiplying, so that means the opposite operation is division. So we divide both sides by 2 to get the answer a equals 7. Have a go now at the two questions on the right hand side and then check your answers. Again, on this next page are no examples, just some extra questions for you to have a go at, and again you'll want to check your answers once you've done them. Now we're moving on to setting up and solving equations. We're told that the perimeter of this triangle is 12. We need to set up and solve an equation to find a value for x. It's really important here that we follow this method exactly. You might be able to already figure out what the missing side length will be in order for the triangle to have a perimeter of 12. However, if you just write down the answer, you won't score any marks in the exam. The examiner is telling us to set up and solve an equation, so we must show that we have used that method in order to get the marks. What we'll do is I'll pick a corner of the triangle to start at, and then I will walk around the shape. As I walk around the shape, each side that I pass, I will write down. So walking along here, I've passed length x. I will then walk down this side, which is of length 3, and because we're doing perimeter, I'll need to be adding up the sides as I go along. Coming along this side, I will have add 5. So, an expression for the perimeter is x plus 3 plus 5, but this is not an equation until I put an equals sign in. Well, the question tells me that the perimeter is equal to 12. So I can write an equation that says the perimeter is 12. I now need to solve this equation. I have like terms of plus 3 and plus 5, so I can combine those to get plus 8. X will drop down, equals will drop down, and 12 will drop down, as I have not collected those terms together. This is now like the equations we saw at the start of the lesson. So to isolate x, I will need to subtract 8 from both sides, and this will leave me with the answer of x equals 4, because 12 take away 8 is 4. Now have a go at the question on the right hand side and then check your answer. Our next example is similar, but the equation will just be a tiny bit harder. We start in one corner and write down all of the side lengths added up. So 2x, add x, add 3, add 4. This must be equal to the perimeter because we've gone around the whole outside of the shape, and we're told that the perimeter is 19, so we can have equals 19. I now need to collect like terms on this left hand side of the equation. 2x and add x are like terms, so that's going to give me 3x, and plus 3 and plus 4 are like terms, so that's going to give me plus 7. The equals and 19 will drop down. We now need to isolate the term that includes the variable, that's 3x. So to get rid of plus 7, we're going to subtract 7 from both sides of the equation. 3x will drop down, the plus 7 and minus 7 cancel, the equal sign drops down, and 19 take away 7 is 12. We're not done because we don't have x equals, so to isolate x we need to undo this multiply by 3. So we will divide both sides of the equation by 3, and that leaves us with the answer x equals 4. Now have a go at the question on the right hand side and then check your answer. In our next example we have a rectangle and we need to set up and solve an equation to find x and then find the perimeter. Here we can't just add up all of the sides of the rectangle because we're not told the perimeter that it should be equal to. So instead we need to do something different. Notice that these two sides of the rectangle have different pieces of algebra. However, rectangles have opposite sides the same length. So this tells us that this side must be equal to this side because it's a rectangle. This means we can write this down as algebra. X plus 5 must be equal to 2x minus 1. This is now an equation with unknowns on both sides, and they were like the questions we were solving earlier in this lesson. So we can solve this equation for x. We start by circling the terms that contain the variable. That's x and 2x, and we need to decide which term is the smallest. That's x. So to undo this x, we need to subtract x from both sides of the equation. X take away x is nothing, so we don't write anything here. Plus 5 drops down, the equal sign drops down, 2x take away x is just x, and the minus 1 will also drop down. We now need to isolate x by itself, so I need to get rid of this take away 1, so we will add 1 to both sides. This leaves us with 5 add 1, which is 6. The equal sign drops down, x drops down, and the minus 1 and plus 1 cancel, so we now know that x equals 6. Now that we have x equals 6, we need to try and find the perimeter of the rectangle. To do this, we will go back to the diagram. Because we know x equals 6, we can actually work out the side lengths. So here, instead of having x plus 5, I can replace x with 6 and do 6 add 5 to know that this side is equal to 11. This side down here would be 2 times 6, which is 12, take away 5, which is 7. This side here is 2 times 6, which is 12, take away 1, which is 11. And we would expect that because opposite sides must be the same length. So because they're both 11, I'm happy that x must be 6. This side here we don't have any algebra, but again, properties of a rectangle tell us that if this side is 7, this side must be 7. So now to get the perimeter, I just need to add up the values on each side. That's 11 plus 7 plus 11 plus 7. So overall, the perimeter is equal to 36. Have a go at this question on the right hand side and then check your answer afterwards. And again, we've provided you with some extra questions for you to have a go at, and again, you want to make sure that you check your answers after you have given these questions a go. On to the final section of the work, and we're looking at rearranging formulae. Our first example is showing how 2 times 6 equals 12 can be rearranged to give 2 and 6 as the subject. In this calculation, 12 is the subject as it is isolated by itself on one side of the calculation. If I wanted to make 2 the subject, I would need to isolate 2 by itself, which means I need to undo the times by 6, so I would have to divide both sides of the calculation by 6. And this makes sense because 12 divided by 6 does equal 2. To make 6 the subject, I would need to isolate 6, which means get rid of the times by 2, which would result in dividing both sides by 2. We can also do the same with algebra. Here, C is the subject of this formula because C is isolated by itself. To make A isolated by itself from the subject, I would need to get rid of this times by B, so I would divide both sides by B. Dividing the left side by B means the B will disappear. To divide the right side by B, we'll write it as a fraction, C over B. To make B the subject, we would have to divide both sides by A. Have a go at the 4 questions on the right hand side and then check your answers. In this example, we need to make 5 and 2 the subject. To make 5 the subject here, I need to isolate it away from the plus 2. That would mean subtracting 2 from both sides. That would make this 2 disappear and it would introduce a minus 2 on this side. This calculation makes sense because 7 take away 2 is 5. We can do the same for 2. I would have to get rid of this add 5, so we would subtract 5 from both sides. Likewise, we can do the same when we only have variables. So here, to make x the subject, I would need to undo this plus y. That would mean subtracting y from both sides of the formula. And here, to make y the subject, I would have to get rid of this plus x. So I would need to subtract x from both sides of the formula. Have a go at the 4 questions on the right hand side and then check your answers. For our next example, we have the formula y equals 4x plus 3. Y is the subject as it's isolated by itself, but we need to try and make x the subject. To do that, we are going to isolate the term that contains x first. So we're going to isolate 4x. That means we need to get rid of the add 3, so we are subtracting 3 from both sides of the formula. Here we have y take away 3. These are not like terms, so we cannot subtract them, so we must just write the 2 terms out like so, y take away 3. The equal sign drops down, the 4x will drop down, but the plus 3 take away 3 will cancel each other out. We're not done because x is not isolated by itself, so to do that we need to get rid of the times by 4 in front of it. This means we need to divide both sides of the formula by 4. Well, here we have a problem because we need to divide y and minus 3 by 4. Well, we can't do y divided by 4, and 4 doesn't go into minus 3 nicely. So just like earlier, when we have a division that we don't feel comfortable with, we can write it as a fraction. That is y minus 3 all divided by 4, and that equals x. Because x is isolated by itself, that means it's now the subject. Have a go at the 2 questions on the right hand side and then check your answer. Next, we have the formula y equals 4 lots of x plus 3. Again, we need to try and make x the subject. Here, we're going to do steps in a slightly different order. That's because x plus 3 is inside a bracket, So all of that needs to be isolated away from the times by 4 first. In order to do that, we need to divide both sides by 4. Y divided by 4 is going to end up as a fraction. The equal sign will drop down. 4 divided by 4 are going to cancel each other out, and that's going to isolate our x plus 3 term, just like we wanted. Now we need to isolate x, which means we need to undo this plus 3. So I'm going to subtract 3 from both sides of the formula. Well, here we have y divided by 4, but then I've got to take away 3. Because y divided by 4 and take away 3 are not like terms, we're just going to write those two terms next to each other. So y over 4 and then a take away 3. The equal sign drops down, the x drops down, and the plus 3 take away 3 have cancelled each other out. So now x is isolated by itself, so it's the subject of the formula. Have a go at the two questions on the right hand side and then check your answers. Finally, the last page of the booklet has more questions for you to practice. So again, give these a go and then check your answers. That was all the work we covered in our lesson at school. Hopefully you found this useful, and hopefully this will be useful for when we come back to school in September.